afternoon, ladies and gentlemen. My name is Ping Xie, and my advisor is Jing Guo. Today I will present my topic on efficient allocation algorithm for virtual machines in cloud computing systems. This is my outline. First is my introduction. We will define the system model, and we will give an example of efficient virtual machine assignment algorithms for virtual machines. Then we will present my performance evaluation. Finally, is the conclusion. Introduction. The virtualization is going popular, so it can make the cloud computing system provide powerful computation ability, large scale and complex computing data management for big data. And a lot of users may rent a virtual machine on a physical machine. So this physical machine may be turned on and consume energy. Each virtual machine in this cloud system could have two information: resource requirements and lifetime. Its lifetime is equal to its execution time. The virtual machine placement problem is an NP-hard problem. We usually use some heuristic to slow it, such as first bit and best bit. We will introduce them later. This paper addresses the virtual machine placement of the cloud system. We tend to minimize the running period and to achieve energy savings. System model. Here we have two sets in the computing system. In cloud computing system, one is a virtual machine set and a physical machine set. Each virtual machine and the physical machine is independent. Virtual machine has no data dependency, and the physical machine will not use their capacity together. A physical machine has four kinds of limited capacities: CPU, memory, disk, and network bandwidth. We assume Vi is I virtual machine for corresponding request I. It's denoted by a full tuple: CIMIDI, NI. Is CPU, memory, disk, and network bandwidth respectively. There are possibilities that user may change their resource requirements. This may cause the original physical machine to be overloaded, so it may trigger the migration mechanism. Here we use the stop and copy migration mechanism. There are two resource constraints. First is the physical machine's available resource must be larger or equal to the resource requirements for I. Second, if a virtual machine subset is hosted by a physical machine, the summation of the CPU requirements must be smaller and equal to the CPU capacity, and so on. Memory, disk, network bandwidth are same. Here is our proposed algorithm. We propose a resource-based first bit algorithm. When the lifetime or execution time of a virtual machine is not provided, the cloud scheduler can assign the virtual machine to a physical machine only based on their resource requirements. The RFFA schema will place the virtual machine on the first physical machine with smaller identities and satisfying the resource constraints mentioned above. So a machine with larger identity can be a higher probability to be shut down and reduce the energy consumption. So we did an example to let us understand clearly. We assume each kind of physical machine's capacity is 150. Here are two tables. First is the physical machine's status and lifetime. Second is the virtual machine's status and lifetime. CP is the current time. Okay, when virtual machine B1 is arrived, the clock scheduler may check the first PM P1 whether the available resource of P1 is larger than or equal to virtual machine's resource requirements. Obviously, the available resources of P1 is larger than the resource requirements of B1. So the clock scheduler will assign the B1 to the P1. And when P2 arrives, the clock scheduler will use the same way to assign the P2, and so on. So finally, we can see V1 and the V2 will be assigned to P1, and the V3 will be assigned to P2. Our performance evaluation. Here we totally use three approaches. Resource-based first fit algorithm, resource-based best fit algorithm, and resource-based worst fit algorithm. Resource-based best fit algorithm is that the clock scheduler will find the PM, which is largest amount of the four resources on the PM, is the lowest among the running PMs, which are satisfied the resource constraints. On the other hand, the resource-based worst fit algorithm, the PM is the highest among the running PMs which are satisfied the resource constraints. The maximum number of users in the cloud system is 1,000, 3,000, and 5,000. A user would have the 20% probability to request a virtual machine every day. Each kind of resource requirements was randomly generated within the range 25 to 75. When a virtual machine was terminated, the resource requirements of the virtual machine will be recorded. The virtual machine's lifetime will be randomly set within the range 2 to 12 days. Each virtual machine executing for 7 days will have a 30% probability to change their resource requirements, and the range of change is plus minus 10%. Each kind of CPU capacity is 150. Here are our performance metrics. One is the average of number of running PMs every day during a month. Second is the summation of average running PMs every day of a month at an overall runtime. Here is our experimental results. When user is 1,000, we can observe that the RBFA has worst performance because the clock scheduler will assign the VM to the RDFA will make the PM low balance. So the clock scheduler will assign the VM to PM, which is coming off. So the physical machine is hard to be shut down. So it has the worst performance. Then RWFA, it will the clock scheduler will assign the virtual machine to physical machine more full, more better. So, but it will cost. So it is better than RBFA, but it will cost a lot of resource leak. And RFFA, it will cost resource leak. It will not cost resource leak as many as the RWFA. So, and the RFFA will let the PM with larger identity easily to be shut down. So RFFA is better than RWFA. And we can find out that the first month, the second month, the running PM is larger than first month. This is because the physical virtual machine number is 0 at the first. So the second month, the total virtual machine number is larger than first month. So the second month running PM's number is larger than the first month the running PM number. And we can see when user is 3,000, the trends are same with the user is 1,000, and so is 5,000. There is another experimental result. We assume that a running PM will consume a unit of energy every day. So here is the total energy consumption during an all-over runtime. We can obviously the RFFA schema has the best performance here. Conclusion. We address a virtual machine placement problem in a cloud computing system. We propose RFFA schema to minimize the running PMs. Because of minimizing the running PMs, the energy savings are achieved. Thank you for your attention.
Okay, is there any questions? Okay, you have a good control on your time. And so for courtesy reason, I would like to maybe ask the question. So in the placement of the virtual machine to the cloud computing system, you mentioned about what is availability. So every users can use the virtual machines in your configuration. You don't. Is there any condition that some user will face that there is no virtual machine to be used? Is it possible? What I mean is you just make either first bit or best bit, but you always have enough resource for the user.
Yeah.
Okay. So in that respect, do you have a calculation on the utilization, that is the power consumption, the total consumption? Do you have a statistic, or maybe it's shown on your figure? Do you have?
We don't have to use the utilization.
Okay, because in the first some of your first slide, you say that if the machine, we can turn off the machine so that you can save more power. So I guess maybe you should, if you have such statistic, then the study will be more strong Is there any questions? Again, if you like, you can raise your questions, maybe in Chinese. That's okay. 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 If there's no more questions, so let's thank the first speaker, Mr. Yin. Our next paper. Okay. Our next paper is so. Do we have the second speaker here? No? We don't show that? No people the second paper is supposed to be on speed-based load balancer for scheduling reduced tasks to process intermediate data of net-reduced application on cloud computing. So do we have Mr. Wang or Zhu or Xie or Tai? No? So we don't have the second speaker, then we have more time.